So what if you had cosine fourth? So this time we are going to have to use the double angle formulas and some clever manipulations. And one sort of general pattern is if the power of the trig function you're dealing with is even, then you're going to have to use a double angle formula. And if the power is odd, then you can do the trick that we did before with a u substitution. So the double angle formulas are only necessary when you have even power of your trig function. So you'll see that as you do some examples. All right, so what you do with cosine fourth is you say, well, cosine fourth is just this thing squared. So the idea is to reduce the power of 4 down to a power of 1. So we can start by saying, there are different ways to write this. I'm going to write that it is cosine squared times cosine squared. All right. And then so each one of these cosine squareds we have a formula for. So that's equal to the integral of 1 plus cosine of 2x over 2 times 1 plus cosine of 2x over 2 dx. So what I'll do for this one is I have 2 1/2 here, so I'll pull them both out as 1/4. And then what I'm going to have inside the integral, I have to FOIL this top. So it's going to be 1 plus cosine 2x times 1 plus cosine 2x. So what that's going to give me is 1 plus 2 cosine of 2x plus cosine squared of 2x dx. So this is a great example. This whole process is a good example of a mathematical process called reduction of order. So I started with cosine fourth, which I don't know how to do, and I reduced that down to a problem that has cosine squared. So, and then cosine squared I can use this for. So you can see how if we had cosine sixth, we would be able to reduce the order down to something with a cosine fourth in it, and then from there reduce it to a cosine squared, and so on. So it could be an iterative process depending on what the power you have is up there. But I'm not going to go higher than fourth power, not for you guys, not at the end of the school year. All right, so what we're going to do from there is we're going to say, okay, this equals 1/4 times. So I'm going to go ahead and integrate the parts of this that I can integrate like I did last time. I'm going to use a nice square bracket here because we're going to have in nested parentheses as we go along. So the antiderivative of 1 is x. The antiderivative of 2 cosine 2x is just sine of 2x. Right? Because when I do the 1 over g prime, it just cancels with the 2 here. So you can verify by doing the derivative of sine 2x, it's actually 2 cosine of 2x. So that actually simplifies a little bit. And then plus, now this cosine squared of 2x, I'm going to replace with this formula again. So I'm going to have integral of, because I'm not doing that integral yet, integral of 1 plus cosine of 2x over 2 dx. Right? I'm not putting a plus c yet because I still have an integral. The plus c is tied up in this integral. So I've done this part of the integral and this part of the integral, but this part, I haven't done that integral. I'm just rewriting the inside. But hey, did you notice the mistake that I just made? The mistake is this. Cosine squared of x is 1 plus cosine of 2x. So cosine squared of 2x is going to be 1 plus cosine of 4x. Right? So every time you do this reduction, the x gets a larger coefficient. All right, so then going on from there, I'm going to keep everything the same out here, just leave it there, and you can do anything with this. It's actually all done. And then let's just see what we can do with this. I guess I did a separate step of pulling out 1/2 integral of, for some reason I wrote cosine of 4x plus 1 instead of 1 plus cosine of 4x. I guess that's just something that happens when you get old. All right, and then I can do these two antiderivatives of the cosine of 4x and the 1. So this equals keeping everything in the front the same, blah, 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 blah. Plus, and then here we're going to actually do the antiderivative. So I need a parentheses around this. This is where I'm picking up my nested parentheses because of the two terms here. So the antiderivative of cosine of 4x, just like the antiderivative of cosine of 2x, we had that on a different page, was 1/2 sine of 2x. So the antiderivative of cosine of 4x is going to be 1/4 cosine, sine of 4x. And then the antiderivative of 1 is still x. And I'm going to close that parentheses. I'm going to close that parentheses. I've now done all my integrals, so now I put on the plus c. Yeah, that says sine 4x right there. Sorry about that. Okay, so then I can just start distributing things. I mean, really, I'm done here, but you're not taking the AP exam anymore. So let's simplify things like your doing things for a calculus professor instead of the College Board. All right, so I'm going to distribute out the 1/2. So I have 1/8 sine of 4x, and then I have plus 1/2 x. You know, if you're pretty good at these things, you can do it all in one step. I'm worried about missing something, so I'm trying to not do that. So then I'm going to distribute the 1/4 x plus 1/4 sine of 2x plus 1/32 sine of 4x plus 1/8 x plus c. And then your final thing that you should look for things like this, we have like terms right there. So let's combine those together and make it 3/8 x plus 1/4 sine of 2x plus 1/32 sine of 4x plus c. And that, my friends, is the antiderivative of cosine of fourth. Some people would factor out the 1/4. I don't know if that's really, or you could have left the 1/4 out. Maybe that would be nicer. I don't know. Anyway, there you go. Now we're going to do another one of these.